guys, welcome back. This is Krishna and welcome to my YouTube channel. We were talking about deep learning model training last time, and in this video we will talk about like what kind of mathematics behind such kind of neural network which I created last time in last video. So I would explain each and every term, like what kind of mathematics there, and how the neural network get trained once we write such a huge number of code, and how model get prediction. So I will talk about different terminologies as well in this segment. So please stay tuned with me and let's go to Google Sheet. So guys, last time we were talking about this feed forward neural network, which is again an artificial neural network. It's just a name, okay, feed forward neural network, but this is a artificial neural network, okay. So here I followed 5 steps. Like first step is load and pre-process the data. Second one is create FNN model using TensorFlow and Keras. Third one is compile the model, train the model, evaluate the model, okay. So I'm just running each and every shell once again. Here I start initiating the first step, okay, where I imported important library to load and pre-process the data. I load the data here from sklearn, okay, and this is the whole stuff which I performed last time. This one is the feature. This is like our cancer data set, okay. We are importing target. This is the very first index of the target, okay. I'm splitting the train test, okay, into 2 parts, so the model gets trained on training data and we can evaluate like what kind of accuracy it is giving us on testing data. So it's all about I explained last time. Here I'm scaling the data. One mistake happened last time. Here I scaled the data, okay, but I didn't pass this in my training, okay. I pass xtrain instead of this xtrain sc, okay. So that was my bad. I will correct it. So yes, okay. So here basically our model gets trained, okay. So the thing is, here I pass xtrain sc last time, okay, and that's why the accuracy was very bad, okay. I will show you once again. Just let this shell complete, okay. So see, this data I passed xtrain ytrain, but you guys have remembered for sure, like last time I scaled xtrain and I stored that scaled data in xtrain sc kind of variable, but I didn't use this here. I forget to use that. So because of this I was getting such kind of huge loss. See, 18% of loss I'm getting, 91% of accuracy I'm getting. Here in validation data, means testing data, which I passed with this sequence, there I'm getting like 90% of loss, and accuracy is 94%. But this can be enhanced. How? So I have to simply pass scale data to this model, okay. So I have to simply pass here, instead of xtrain, I have to pass xtrain sc, which is my scaled data variable, okay. So once I will run, so this 19% of or 18% of loss will reduce up to 10, or you can say 9%. Let's run this and we will see. So I'm running this shell. See, at the end we will get, see, I'm getting 6% loss only, okay. And previously when I didn't pass scaled data, it was giving me like 18% loss, okay, and accuracy was 91%. But this time when I'm passing scaled data, it is giving me 98% of accuracy, which is quite applicable in the market. But see, again, here I'm getting a huge loss, okay. So for this I have to tune my model. So I will teach you later on about this. I just want to tell you what kind of mathematics behind it, how this model get trained, what happened in neural network. So simply in this video, I'm going to show you the neural network architecture, like what is the mathematics behind it, okay. So let me use my marker and this. So see guys, first of all, I would like to tell you like how neural network work. So I just want to show you a simple neural network in visual form. So let's take one example. So there are three layers, okay? Means in this neural network, which I'm going to use to demonstrate how neural network work behind the scene. So I just want to show you graphically like what happened, what kind of mathematics being used by neural network, okay? So for that, I have to create a neural network architecture, you can say architecture. Okay, I will mention each and every kind of concept here. So let's see. So suppose I have a neural network with two neuron at input layer Okay, so let's draw that first. Let me draw it. So this is my first input layer neuron, and this is my second input layer neuron. Okay, now with this I have to mention some more things. So this is called input layer. Okay, this is my input layer, let's say. Similarly, I have one hidden layer. So this is my, let's say, hidden layer. Okay, where again I have two neurons. So let me draw that. First neuron and second neuron. And there is one output layer. Okay, so this is my, let's say, output layer. Okay, there is one neuron. So this is my output layer. Okay, so there are three layers, means the neural network which I took to explain you everything behind the scene there. That's very simple neural network. Okay, where there I have two neurons at input layer, two neurons at hidden layer, and one neuron at output layer, and there is only one hidden layer also. See, this is one hidden layer, this is called hidden layer. Okay, so this is called one hidden layer. Okay, but if somebody will ask in the interview, let's say, how many neurons there in this hidden layer, so you have to say two neurons we have in hidden layer. So keep this thing in mind. Okay, so let me erase this. Okay, and now let's say I have a data where we have two feature, x1 feature, and this is called x2 feature, and this is our target. Okay, one more important thing you have to understand: this neural network is not a magic. Okay, it's simply the concept of mathematics. Okay, so neural network use equation of line, which is y is equal to mx plus c. Okay, here m is called weight and c is called bias. Once again, w is called weight and b is called bias. Okay, bias. So w stand for weight and b stand for bias. Okay, so keep this thing in mind. So this time the equation something look like in the thesis paper when you will understand about neural network, and you will go through the documentation, you will definitely came across with such kind of formula, which is w x plus b. Okay, so this is the same. Okay, there is no difference. Okay, so initially what happened, see, in this data set we have two feature column, right? So each and every feature column will pass to this input layer neuron. Okay, and the other feature column means whole data at once. Okay, it will pass to the second input neuron. Okay, so keep this thing in mind. So I passed this. Okay, now what will happen next? So suppose in this I have like 1 2 3 4 such kind of data. Okay, and 7 4 3 2, it has some target, let's say 0 1 1 0. Okay, it's a binary class. Okay, so there are only two class, let's say. So this whole data, this x column data will simply transfer here like this, 1 2 3 4, like this. It will transfer here. Okay, so the value of x1 will simply allocate to this neuron. Okay, and the value of x2 will look something like this, 7 4 3 2. Okay, which will shift to this neuron simply. Okay, if I have one more column feature, let's say x3, the whole data will shift to one more neuron. Okay, something like this. So keep these thing in mind. Okay, this is our x3, the whole data will shift here. Okay, and that data will consumed by this neuron. Okay, but in this case right now I have two neurons, two input neurons. Okay, so because I have two feature x1 and x2, that's why I took two neurons, because I have to explain you a lot of things. I have to write it on the screen for now, so that's why I'm taking two neurons only. So let's talk about this now. This is an interesting part. You guys were thinking like, what is this now? So this is very important. Let me draw it first. Okay, just to make it different. Okay, I'm drawing like this. Okay, you can also create a solid line as well instead of dotted line. Okay, so now this is called weight 1 1, and this is W12. Okay, similarly this is W21, and this is W22. Okay, so these weights basically consumed by this neuron and this neuron. Okay, so this neuron basically consume this weight. Okay, and this weight. All right, so here I can simply mark them with some different color. This weight and this weight consumed by this neuron. Okay, and it will simply do some calculation, so that will store inside a variable called z1. So in deep learning or neural network books, generally this y, which is equation of line, denoted by z. Okay, so keep this thing in mind. Okay, don't get confused. So now I want to show you some calculation, but there is one more parameter called bias. So this is b1. Okay, now this is I'm talking about equation of line have some intercept. Suppose you have a equation of line here. Okay, so equation of line is y is equal to mx plus c. Now what is c? C is nothing but this intercept which is cutting this y-axis somewhere, so that is c. Okay, similarly, because this is inspired with the equation of line, only the values or alphabet get changed, it simply follow the same rule. Okay, there is no differences. I will tell you later on why this bias is important. Okay, I will let you know, but for now this is also use b1. Okay, and this will also use b2 bias. Okay, different bias they will use, different weight they will use. Okay, so everything will be different, and it is assigned by neural network randomly. Okay, there is no such kind of intention that we intentionally provide a static value. No, we cannot provide a static value. It picked by neural network itself randomly. All value should be picked by neural network randomly. Okay, so it is a very important question in the interview, like how weight assigned in neural network. So many people get confused and they used to speak like, uh sir, neural network weight initially assigned equally. No, that is not true. It's assigned randomly. Okay, let's move ahead. So it will create z1 formula, the z1 calculation. It will do z1 calculation, this neuron. Okay, this neuron basically has two part, summation part and activation part. Okay, but right now I'm just talking about summation part. Okay, I will talk about activation part also. So let's see, z1 is nothing but the equation of line. It will use w11 x1, because this w11 is coming from this x1, and that's why I'm using here x1, w11 x1, okay, plus w12 w12, and now what is it, x2, because this is coming from x2, right? So I will mention here x2, and now this is b, bias, okay. So this is equation of line. Now you guys will think equation of line has only two parameters, right? But you are using three. I will say again, this is the equation of line, okay, because this is not on 2D plane, this is on 3D plane, you can say. So this is a kind of a different hyperplane we are talking about, okay. So this is equation of line. Now here again z2 we will create, means neural network will create using this neuron hidden layer, okay. So it will use w21, which is this, coming from x1, plus w22, which is this one, coming from x2, okay, plus b2. Now this is the mathematics behind the scene, okay, what neural network used to perform all the time, okay. So now this equation of line is a simple straight line, okay, but we have two class in the target. See, we have two class in the target, 0 and 1. See, there are 0 1 1 0. So if I will ask you how many unique values are there in this, you will say 0 and 1. That means there are two classes, right? So whatever data inside this, let's say we have 4 data set, okay. So if I will put this 4 data set on this hyperplane, or let's say, let me create something like this hyperplane, let me use different color, and a equation of line is simply going through, so it will not able to differentiate these two classes into different group. So what we can do here, we have a concept called activation function. Activation function, now what it is, activation function is a kind of function which help to deviate, to transform the equation of line in different shape. Like how? So basically there is a activation function being used, by this neural network, okay, at hidden layer is sigmoid, okay. Just try to note this all thing, okay, because these all are very important, these are basic, okay. Interviewer always go in core, okay, they didn't ask you higher things initially, okay. So these are very important. Even I also face this kind of question in interviews, okay. So sigmoid basically used to differentiate two classes, okay. It is perfect with that. Apart from this, we have more activation function, but I cannot tell you each and everything in this video only. I will create a activation function video where I will talk about different kind of activation function in different videos, okay. So don't worry. Right now I'm talking about sigmoid function. Sigmoid function is nothing but a kind of mathematical formula which use 1 upon 1 plus e to the power minus z, okay. Now what is e? E is a constant, okay. A scientist gave this constant, and this is z. Z is nothing but equation of line. This is -1. So -1 generally represent the probability of first class, okay. First class. Now what is first class? See, here we have two class, right? So let's say this is my first class and this is my second class, okay. So what is the sigmoid function formula for second class? I will say it is p0 1 upon 1 plus e to the power z. That's it. This minus only removed, and it simply start indicating second class, okay. So this is the formula. Well, anyways, this I have to denote it using this sigma function. So this sigma basically used to denote activation. So inside this sigma we pass this equation of line which we get from this neuron first, okay. So this z1 simply came under this activation function, and the line which was going something like this straightforward, okay, this straightforward line was going something like this, which was not able to classify these two classes into two different classes. So what happened? So when we apply this activation function, it simply help us to deviate the line and see what happens. It basically make the line something like this. Now what happened? Here we have, this line between 0 and 1 only, okay? If you will draw a line here, let's say it is 1 and this is 0. So this line basically tends to touch this x negative, okay, and this is x positive, okay, and this line from upper side try to approach this one, okay, but never approach this one, because this is the equation of line. This is a meet somewhere at infinity, and infinity has not been introduced so far. So we always used to speak like it will touch somewhere, but that is infinity. We don't know about infinity at all, okay? None of the mathematical person has introduced the value of infinity so far. So we for now used to speak it like it will touch line somewhere, okay? So basically this activation function change this straight line into such kind of curve line, and this is the use of activation function. Activation function simply change or transform the line into this kind of curve line. This is called activation function, keep in mind, okay? So activation function is simply used to transform the line, the straight line, to just categorize our classes into different classes, okay? So when we apply this activation function, it gives us a output. Let's say the output, I'm saying a1, okay? Again, here again we have like a, I'm passing this z2 into activation function. It will also give me some output which is a2, okay? So now again, because this is a neural network, right? So I have to pass something to this neuron also. This is also a neuron, output neuron. And from here, I have to pass something to this neuron as well, because these all neurons should be fully connected. This is a fully connected layer, okay? There is no any kind of skip connections, okay? Each and every neuron are fully connected with their adjacent neuron, okay? And this is adjacent neuron, okay? See, this is adjacent neuron, means this is the neuron next by this neuron, okay? So that's why this neuron and this neuron and this neuron and this neuron are fully connected to each other, okay? So now what happened? In this case, the output of this activation function, which is a1, will pass to this. Here we were passing x to this neuron. Now this is also a neuron. So what we can pass here? So here we were passing x, but here we do not have anything. We have an output that is a1. We will pass this a1 to this neuron. Simple. Similarly, here we don't have anything. So what we have? We have a2, which is the output of all the operation which happened on this, and it simply gets stored inside a2 variable, and we are using a2 variable here as an input. So whatever output we are getting at this layer, we will use that output layer as input to the adjacent forward layer, okay? So here again the same operation will perform. So again, here we have weight also. So let's say this time the weight is w31 and w32. So what will happen? W31 multiply to a1, because this w31 getting multiplied to the output of this neuron, and the output of this neuron is a1, and that's why I'm multiplying this value with a1, plus this w32 is the another weight from this neuron, which is the output uh, from this neuron. So w32. Now, what is the value? Means using which value we will multiply this w32? So we will multiply the output of this neuron, and that is a2. Now again, we miss something, that is bias. Again, B3. So I will simply have to apply B3. Now, what will happen? Simply, this output neuron, also using sigmoid function. Now, I would like to recall you what is sigmoid function. I just told you sigmoid function is nothing but a activation function. See here, you guys have to make the note of it, okay? Because in this video, in this single screen, I make a lot of things, okay? So you guys have to go through my video properly, and then you have to make a note of it, okay? Otherwise you will not able to understand, and this is really very much important, I'm telling you. So this is sigmoid function simply apply on this Z3 again. So if I will apply sigmoid function on this, I have to pass here inside sigmoid, and it will simply give me the output. So this activation function simply apply on this, and our model get trained, okay? So this is the whole architecture of a neural network, okay? Every neural network work on the same. There are some hyperparameter tune like dropouts, okay? So I will let you know about it in the further videos. So guys, I hope you like this video. If you really like this, please like, share, subscribe, give me a thumbs up, comment me, share this video to your friend, family, colleagues, and thank you very much guys to stay tuned with me. Thank you very much.